Yeah, hi guys. Yeah, I can show the demo which I did. Okay, so that's implementation on Postgres. Sorry for Eden. I hate all these commas and stuff, but you should be able to read it as a JSON. Yes, just move the column to the other side. The link is published in Zulip, so you can play with it. As well, there is some button so you can materialize the view. You can save the view definition as a FHIR resource, and then you can materialize at that moment. It becomes a real database view, and then through the query, you potentially may run the queries on top of these views. This is a Postgres implementation, work in progress. What important stuff we found that there is a semantic of inner join and the left join. And I think this is one of the topics we can discuss probably today. There are a few options. We can have different names for that, yeah. Like try to find the different terms for left join and for inner join, or introduce some modifier. As well, we should decide, yeah, if we go with one name and some modifier in a DSL, we potentially should decide which one is a default, yes. And I think I agree that the inner join may be the default. But if we will be able to find the two names for that, it would be even nicer from my point of view.
Yeah, it's like, I mean, I can go back and forth on whether inner join or left outer join is the default. I lean towards inner join, and we can touch on that. I comment a little bit on the Zulip for that front. But yeah, I like I think having different names rather than a modifier seems clear to me. It's like fewer fields and that sort of thing. So, but I'm not sure if everyone else has the full context for that, because unless you followed along in the Zulip discussion.
I can explain the context. Yes, so when you expanding nested elements, so there may be two type of behaviors. So if there is no such element, we can just remove the record. So from the result, and this is going to be like inner join. So we inner joining the, let's say, the resource with its elements, and if element doesn't exist, the whole row disappear. So this is inner join behavior. Or we have a nulls if this element doesn't exist. So this is exactly what the left join do and the inner join. I think there's use cases for both of them. With the inner join, it is very convenient because if it play a role of filter as well. So you should repeat the filter again. So if you're expanding, let's say, the blood pressure elements, components, if they don't exist, you don't even should filter out the resulting row. But sometimes we know that there's a lot of optional elements in a FHIR. So, and sometimes, yeah, you want to keep it as a null. Yes, so just no data, but the whole record still valid.
With this new paradigm that we're experimenting with, is there still the possibility to have things come out as arrays?
You mean arrays as a column type?
So maybe I'm still catching up here, but we were at one point sort of having the possibility of sort of not unnesting, and for backends that support it, we would like leave it as an array. And I was just thinking in my head, what would the difference be between like a null and an empty array, and in the context of like a inner join type logic?
So maybe it might be easier to kind of work through an example. And so this is one where I think that semantics are, this made me think like inner join makes sense. So essentially, if we if we wanted to create a table of patient addresses, we're grabbing patient, we'll grab the ID, and then we could grab other fields as well. But and then for each address, and we haven't quite landed whether it's going to be like a lower camel case. So that's just a placeholder for now. So for each address, which is a FHIR field, we then select the fields from that. And we kind of like the current behavior. I think this would kind of kick out what we'd expect, a row with each city and zip code. So with regards to like the outer, it's like a join, and then we'll touch on like the array questions as well that John brought up. So I think maybe the question at hand is whether do we is the default behavior for this for each is an inner join. So it does not, so if a patient has no addresses, we would not see a patient row in this table. So I think that's what we're leaning towards. This would be an inner join. And then, but I agree with Nikolai that there are other cases, perhaps not this one, in which an outer join or a left join is desired. So this, if we had like a for each outer or for each left, or we have like a for each in another field that says type, left or something like that, then this would produce a, this would basically produce a row per patient, even if they didn't have an address. I don't think that, that's probably not great for this particular example, but there are other examples in which you do want that. So I think that's the first question at hand for context there. And then I think to touch on John's question, so the for each behavior, that one explicitly, and kind of the way we have it spec'd out now, is explicitly unrolls it to like a row for each value in the select items. So if the select happened to select an array element, like in the next, then that array element would be, continue as an array. So like the for each is how we explicitly unroll repeated fields. But you can still select repeated fields. Like if we put a select like address.city here, that would create like an array of all the address.cities for the patient, because it's not in a for each. Whereas a for each explicitly unrolls rows for each item in that value there. So we can still support arrays in that. So as a result, because of if when just selecting array, an empty array would just be an empty array. Now, if you're doing a for, so that would still be the case here.
So there is no conflict because it's a different keywords. So if you say for each or from, it will be unnested. Yes. In a select section, it's even if it's complex type or part of the resource, it will be selected as is.
Yeah. We have like some from examples, and it's much more complicated, but I can scroll down to like the let's see, we have like a blood pressure example. So well, this one we use some constants, but we say like from, but as a convenience, rather than having to type the whole blood path or blood pressure path, again, we basically declared a constant. There's the systolic blood pressure component. That constant comes from this expression. And so it's just long. I scrolled off the edge of the screen there. And then we have from, this component, we can select these values there. So this is kind of how we landed that. We went back and forth a little bit on whether it makes sense to have this notion of constants, because it adds another element to this. This adds a little bit of complexity, but I think that the folks, the group subset of us that were chatting about it, which have tentatively have reached the conclusion that this is justified because it can be convenient in other cases for like readability or understandability and that sort of thing as well, or just not wanting to. So if there's like a code value or something like that, maybe it's convenient to plug it in as a constant and name it so you can see what it is. So that's the reason why we added this as well. But that's a little bit of an aside, because like the key here is to show this is a from, which would not iterate through each one. It would just get the values, as Nikolai pointed out, as opposed to the for each, which we saw in the address. And I'll scroll back. Yeah, actually, this is a more involved, this is a little more complicated patient address example. But yeah, there's the for each for the address that does unroll it.
Generally speaking, I think that having an option of left outer join is going to be very helpful, because that will produce consistent results. Anytime you want to persist it as a CSV file or Excel, so having that would be much easier, because you're going to have a consistent string of values.
There's a lot of use cases where the left join semantic is more convenient, but there's other use cases.
Absolutely, there are others. There are others.
Yeah.
There are other.
Yeah.
I understand,
That's
but as I
why
said,
ideally we can have two different keywords for that, like for each for inner join, and I don't know, unroll or expand for. Yeah, so we can, if you have some candidates for these terms, yeah, please post in the Zulip chat. Yeah, we will now have like flatten for each, flat map. So we discussed like dozens of different terms. They all have different connotation and still intersecting with each other, but eventually we can design decide that this keyword will be used for left join and this for inner join, and just put it in documentation. Yeah.
It sounds like the way we're gravitating, and Nikolai, I think I agree exactly with what you're describing, is that yeah, we're leaning towards having different keywords for these different semantics. The default of for each will be an inner join, and we need to come up with what other keyword we would use for an outer join, and we can brainstorm that out in the Zulip maybe.
ChatGPT suggested unroll and expand. There's a flatten option and good as well. So I like flatten. Maybe it's longer keyword, but it's still like what people expecting.
Yeah, I get him. I mean, I tend to make it when we could consider something like more explicit, like for each left or for each outer. That is longer as well, but it gives a user a bit of a better indication of the behavior there. But
okay, maybe prepare the option and just vote for that because I don't see, or maybe somebody will.
Sounds good. Yeah. Any thoughts or strong opinions or ideas on that? I mean, I think we could take this to the Zulip pretty easily as well. But
I think for each makes sense to be. I don't think unroll is objectionable, but something along, yeah, either unroll or something similar for the alternative. I think that could be right. I know what you're saying, Ryan, about sort of making it a bit more explicit. But I think the for each actually, it almost implies inner to me. Yeah. So if we could find it another name that sort of complements for each and sort of fits nicely in the outer space, I think that would be, yeah, that would make sense to me. And by the way, this all seems really nice and makes a lot of sense to me actually. And I think looks like you guys have actually made a lot of progress and it looks good.
And John, it's great to hear that this overall approach makes sense to you, since given all the work and how you've done in space and the pathling and that sort of thing, the fact that this resonates is, I think, great. But I think the big breakthrough is that we got a little bit of a look at the thinking behind the FQL from the FHIR folks. You know, the FHIR query language, and they had some, I think, good ideas in that space, and we borrowed a little bit of that here. But so yeah, I think that really helped us make some good progress. But yeah, I'm feeling fairly good. There's a number of details like this to work out, but I think I feel pretty good about the structure here as well.
Another topic. So you showed the constants, and we agreed that it should be simple logic, like just string templates. Yes, so it should not provide more complicated logic that just replace the name with the rest of the path. And it looks like quite nice because sometimes, yeah, the extension URLs are long and stuff like this, so you can put it outside of the expression.
I actually like that it's constants now, because it was actually kind of bugging me that they were called variables when they're not actually variable. And because the semantics of the percentage sign thing in FHIR is sort of like a constant value.
So on dev days, we as well discussed very interesting option when the clinical quality language can be potentially compiled into SQL on FHIR version 2, into the set of flattened views and SQL queries on top of it. So this direction sounds very interesting as well, because it doesn't force you to even have the FHIR storage to run the SQL metrics.
I'm trying to think of like in a CQL space, like looking at these. I mean, these are these obviously pull from FHIR fields, but the names of these flattened fields are very different, and the structure is very different. But of course, CQL is referencing the FHIR fields directly. So is there like a model in which the CQL would be updated to pull from a flattened FHIR model, or is it, or would CQL be used to create like a define like flattened FHIR views that would build on top of?
Yeah, that's the idea, that if you have a set of metrics, so some code analyzer can go through SQL rules, because usually SQL rule doesn't use all elements of FHIR. Yes, they use sometimes very small subset of it. And after analyzing all these rules, it can potentially generate the flat view.
Oh, I see what you're saying. We had something that analyzes the CQL, generates the flat view, and then basically finds and replaces in the CQL to point to the fields in the flat view, and then you could run it like as SQL.
Yeah, and the rest of SQL is going to be translated on the SQL queries on top of these flat views. And that can be the kind of compilation, transpilation of SQL to SQL, not directly, but through this intermediate phase. And this may be interesting because different engines may be used and so on and so on. Yeah, and even data can be populated from legacy schema, not from FHIR.
Sounds like a pretty cool idea, but cool. Well, I saw Ethan raised a hand though, so yes, definitely want to hear from Ethan on this.
Yeah, well, I wanted to point out that CQL actually is model agnostic, right? So most CQL in the world right now is actually written for QDM, not for FHIR. So in the infrastructure for CQL, there's this whole concept of a model info, which defines all of the elements and their types. I would imagine it might be possible to take something like this that we're looking at and potentially dynamically generate a model, which you could then write CQL against, which would prevent you from using anything that doesn't exist in the schema model we're creating. Now, of course, one of the goals would be that CQL targeting FHIR would just work, right? We would create views for CQL targeting FHIR, not the other way around. But I wanted to point that out because it's an interesting use case that could come about in the future, which is if we reach a level of maturity where quality measurement schemas like this are kind of standard, or at least there's one that is used heavily, one could create a model, one could then declare that their CQL that they're writing uses that model, and then they could adjust their CQL to use that model, and then it would be really, really one-to-one. It would be really easy then to translate into SQL because you wouldn't have to deal with the weird nested paths and the flattening and all the other stuff that CQL does when you attempt to do something like claim.item.diagnosis. Whatever, right? It's a thought. It's a direction we could eventually go with this. I just wanted to make that clear because CQL does have its own modeling language that is separate from FHIR itself.
I would like to ask guys, how about status of implementation?
Yeah, so and unfortunately, like I had other demands over the last couple of weeks, and so I had not been able to jump into this. Although, but I'm hopeful I'm going to be able to get back into it like next week or so. Yeah, we'll make progress on this. I haven't really done it yet, but we'll jump into it. And I actually had another engineer at Google reach out, like with interest in just jumping on this as something of a side project as well. But for those of you without like full context, we've been experimenting with like a Python library that basically basically does this, but offers like a Pythonic front end to it, so to help build the FHIR path expressions. But kind of the goal that we have is for like this to basically have a Python capability where we could run these, build the flattened SQL just in a Python, so it makes it really easy for like a Jupyter Notebook user to plug in. And we're trying to provide some niceties to make it actually easier to build the FHIR path expressions, like by using some autocomplete capabilities and that sort of thing. And that we have a version that works, but we haven't. The big thing we haven't added it yet is because this whole sort of nested select structure is new. We haven't added this to it, and so I think I need to figure out the best way to do so. But it's definitely my intention. I just wasn't able to get to it in the last couple of weeks.
Where we're at is I sort of did a partial implementation of the first cut of what we did. I got a sort of a ways along with that. It enhanced my learning, helped me to sort of participate in the discussion. Then I sort of went back to extract, which is our operation that sort of resembles this, and I started adding some new features that came out of this, so things that it didn't already have, like the optional sort of unnesting and that sort of thing. So I've done some foundational work, which I think can translate to a few different ideas. And I haven't really touched this this side of it yet. I did sort of jot down some thoughts. So, because we were having that sort of debate about, macros versus constants or variables and all that sort of stuff. And it sort of occurred to me that there's sort of pros and cons to that. And where we've landed is sort of constants. And I think that's good in a way because unlike macros, constants can be used as sort of caching hints. And I'm not sure, Nikolai, how you implemented this in Postgres. Maybe you could give us a bit of a higher level walkthrough maybe, but how did you actually implement like the the constants that get reused through the rest of the query.
Yeah, but as we discussed, for the constant, it can be just replacement. So it can be done at the first phase. You can just replace like this constant with its expression, and then compile the expression, because no other smart behavior. So it is really just templating, just to sugar to move, to separate like long strings from the main expression.
So say if you have a repetitive expression, so I guess one of the differences about pathling to this is that this is constrained to a single table, I guess. So we don't have to worry about potentially joining across to other tables or whatever. So you've got all the columns in the table already. And I guess it doesn't really matter if you have sort of repetitive expressions, because that's not really the way you're implementing it.
I can tell that the general flow for the Postgres from select or for each stuff is transformed into not left or inner, join lateral, unnest. And then going through this whole view definition, you're just building very long join expression, and most of FHIR paths is transpiled to JSON paths. I think in case of BigQuery, it's going to be nested queries or something like this, or common table expression, but so that's how it works. And implementation was quite straightforward. So that's what I can say. And I think that the general pattern for implementation, so that all this for each section will be just translated into lateral joins.
Yeah, I was just going to say that is our efforts in BigQuery and space that were very much the case. It just is translated into unnest expressions in BigQuery and join to it inline, and actually works pretty well. We haven't added like all the select stuff, but the stuff we have added, it's working pretty well for navigating like repeated fields and that sort of thing. But yeah, it's a different implementation, obviously different SQL than what Nikolai is generating, but it seems workable.
Is it problematic, John, in Spark? I know you use some smart stuff, like do you have some subset of FHIR paths implemented in Java for Spark, or are you still translating it into joins or something like this?
The way I currently do it is quite different. I still don't know whether it's the best way or not. I'm experimenting with different approaches. The way we do it actually is to explode, which is kind of similar to a lateral view. But when we do that, we actually create like a monotonically increasing ID on repeating elements. So we just explode everything out in a cross join. Then we basically do a big filter on the things that need to match up. So it's kind of probably the same thing that's actually happening under the hood with what you're doing, but it's kind of driven sort of from a programmatic perspective rather than, because we don't generate SQL.
But you potentially may explode only fields which are described, yes? Or it is kind of more convenient to explode everything and then filter it?
I think it's more performant. Like I said, I haven't 100% landed on that as the final implementation, but it certainly does work that way.
Essentially, your implementation even more closer to Josh demo than to SQL translation, because Josh, that's exactly what he is doing with JavaScript. Yes, he's going through the ND JSON and flattening and exploding. Yeah.
One of the things about Spark is you don't want to get in the way of the optimizer. So you want to make it nice and clear and have sort of columns that can be traced all the way back to the source files, and you don't want to do sort of any sort of fancy transformations that kind of interrupt the optimization process. That's sort of one of the performance considerations. But I mean, from a semantic point of view, I think we're doing exactly the same thing, and I just need to catch up and get it all done, and then we can compare and contrast.
Actually, I think it's great that different implementations of this spec seem workable. I think that's actually quite a positive sign, and definitely it's like a and I hear you like on sort of the plugging in a way that's natively capable to the Spark ecosystem. I mean, the fact that seems possible here, I think, is great as well. So yeah, this seems like positive news to me. And I mean, on our BigQuery experiments, yeah, we're more directly generating like SQL all the way down with nests. That seems to be working well also, and I can see Nikolai and Josh's efforts too. So kind of exciting that we were able to see a variety of very different technology stacks where this applies, which I think is a positive sign.
Yeah, the other difference in Spark is that you kind of like you can create a Spark package, and you create, say, a method that passes back a sort of a query, an uncollected query, which the user can then build upon. So unlike the other engines, I suppose you're not actually just giving back a finalized table, you're giving back like a query sort of in train that Python or Scala or Java users can actually combine and do further transformations on. It's not until they actually pull the trigger at the end of their pipeline that everything gets sort of executed. That's why I didn't mind you saying like this, we constrain this to a resource, because you could have numerous of these views in Spark, instantiated around the place, and then joining them up and doing further transformations on them as part of a larger pipeline. And it'll be good to sort of get a more complex demonstration happening as well once we've got this all implemented.
I think this is our strong part. So that we're not just writing spec, but we'll have like several working implementation, and this this is very awesome actually. Spec and implementation at the same time. Yeah.
I have a question. I'm new here, so probably it's kind of repetition, but as far as I understand, now we convert FHIR resource to a flattened representation, and further in the pipeline, we want to query these flattened tables and derive some new tables. Is this part covered by this project or not?
The approach that we've kind of thinking about so far is kind of actually breaking things down into two phases. And actually, we have talked a little bit about it in these. And so, so maybe I'll just do like a quick overview of the model. So one is like for the FHIR itself, we need some sort of physical representation, whether it's a JSON in Postgres, or whether it's specific columns in BigQuery, or whether it's a data frame in Apache Spark. So yeah, you need the full FHIR resource there. So, but we're not going to over specify that. There's flexibility in that. Everything we're talking about here is what we call the view layer, is creating these flattened views per resource. So since that's your view, but then we're kind of deferring, I think, what Alex, what you're describing to what we call the analytics layer. And this will be very much kind of deferred to the technology stack of the user. So if you're in a Postgres database, and it should be able to, once you have flattened FHIR views, it should be a lot easier to write queries like in Postgres tooling or your favorite business intelligence tool on top of that to do all that. So we're intentionally not specifying things on top of the views. We basically feel like once we have nice tabular views, things get a heck of a lot easier, and people can use whatever tools they want over that that matches the stack. So that's kind of like the philosophy we've taken so far.
Yeah, but from my side, I still hope that we will be able to kind of have something like portable queries on an analytical layer as well. It's going to be much easier, because when the views are flattened, like use ANSI SQL or something like this, so the people can distribute the queries on top views as well, and less variability than on working with the nested data structures, which are not standardized. Yes, so that's probably we will discuss. Yeah, after the view layer.
Yeah, it looks like a big part of logic can be in this part, how we derive secondary flattened tables with different joins, etc.
Yeah, that's another interesting topic. So we have like DBT style building views of views, yes, and we can probably discuss something like this. I don't know, are we going to standardize it or not, but at least we should discuss, because now we're building, so we treated ourselves by the view on top of just one resource type. And we definitely understand that most of useful views going to be some joins, like encounter plus patient plus something else. And are we going to specify in a DBT style or I don't know, looper style. So we are not yet sure, but we're going to discuss it as well, like the second layer. So probably we can use something like DBT to describe like joined views. But this is, again, this is for the future. So we want to get this first through as a view definition.
Yeah, and I can see like multiple paths there where you might have different groups. Like there may be a DBT community for FHIR that really kind of specifies like some common DBT patterns on top of that. And there may be, I don't know, like a Tableau community over using the flattened FHIR that specifies patterns for that case as well. So I can see like a few different paths there. But yeah, definitely would encourage like if there's like interest groups in like a particular stack like DBT, and we want to come together on some conventions or standards, for that stack, then yeah, I think that makes a great deal of sense. At the same time, we preserve flexibility so people can use whatever tool they want over the flattened views. But yeah, thank you for bringing up that question. I think that's a super important piece of kind of the key here, and also a lot of the reason why we very, very consciously restricted these flattened views to be basically one resource expands to zero, but expands to one or many rows, or actually 0 to many rows. And we do not do joins at this layer, just because we explored that path with it, and it gets pretty complicated and pretty difficult to port pretty quickly. So we kind of punted on that and said, hey, we're going to create per resource views and let SQL do its work its magic to join them together on top of it.
Yeah, thank you for explanation.
And right, you had another topic.
There's a few other things that we can get into. I'm tempted to kind of, but I don't have anything formally prepared for it. So, but maybe just a preview for things that we can discuss next week. Well, the spec isn't complete yet. I mean, there's still some open questions there. One of the open questions has been dealing with like additional like metadata that might exist for a field. Like, for example, we might want to provide some hints to the database that, hey, given a type hint of like, hey, that we know that this field is a date time, and in some cases we can infer that from the FHIR types, but in other cases like that, if I have like a patient demographics table with a birth date, I might want to try to enforce that those birth dates are always full dates, because in many data sets they actually are, and a flattened view in the database would want a date type as opposed to like a date or a year or something like that, that you get without kind of refining that. So yeah, I think there's still those date questions that we can dig into. And another topic that came up that I actually maybe could be along those lines is if we can find some sort of convention to add like experimental or system specific tags to like these expressions. And there was like, I think a couple of weeks ago, and there's some discussion of, hey, can we use this to project or convert FHIR data to OBOP? And I think the initial reactions, well, I mean, we create flattened views, and then we can have like DBT or something on top of those flattened views to convert into OMOP, which I think makes sense. But it turns out like it didn't seem like we were that far away from being able to use these to map these to OMOP. And so maybe there's like some like system specific metadata that we could attach to these things that would kind of inform like the code value translation or something like that. So I think there's room for like having some sort of special like label or tag namespace where I could add something to this select, and maybe it's like just we use some convention of like prefixes with an underscore or something that it's hey, this is an experimental or system specific tag. Implementations are not required to understand it, but those that do could apply their own behavior to it. Anyway, those are just like totally half-baked thoughts, ideas that have come up in discussion. I just wanted to mention it as perhaps topics for future weeks.
Yeah, this is a great idea. And so in my demo, I implemented like type, which just do the cast to Postgres type. Yeah, and I agree that if we will have kind of extensibility way to extend these view definitions, yeah, that's really very nice.
The other possible way to do it is to use type domains in FHIR. You could keep it in FHIR. And in FHIR, you already have like a way of namespacing type specifiers. Yeah,
we can discuss it. For me, it looks much simpler to just introduce ANSI SQL types or as a type attribute, because it's usually done outside, at least in our implementations. Yes. I'm getting too deep into FHIR. There's a lot of complexity with the FHIR, so I don't want to put more there. It's much easier to interpret just element attribute with a type as ANSI SQL type or something like this, yes, than parsing the FHIR annotations or something like this. You know.
But the ANSI SQL type isn't going to really tell you enough information to do the sort of thing that Ryan was talking about, like with dates, like say converting a birth date, partial birth date into a, there's still a bit of inference there, isn't there?
Mm-hmm. Yeah, we may introduce something like processors on a table or on a column level. Yes, I don't know how to call it. Yes, some functions. But potentially, yeah, this function may exist in FHIR, but yeah, we should decide. One of option we discussed, like converting everything to periods, yes, like even just daytimes. And this looks like very special function. But if we decide to kind of be quite flexible with the FHIR, which provide little bit more expressivity than we need, yes, because if we introduce like as a period function, then somebody may put it in the middle of the expression or something like this, and that may become the problem. Yeah.
I was just going to say we've still got some work to sort of really nail down that subset of FHIR, like that limited subset.
By the way, should be yeah, I think if we can ping this again to the Zulip, but yeah, it's I mean, all this should be up on GitHub, but yeah, I mean, this is kind of like the working stuff we have now. I mean, kind of the approach that we've taken since this is up on GitHub is like if there's I mean, if there's specific changes or enhancements or addition to the spec, we're just discussing via GitHub issues, and then it's been a good approach. So, for example, in this type discussion, I mean, well, Nikolai, if you're interested, since you've done some type exploration, and if you want to log a GitHub issue with a type proposal that we can discuss there, yeah, and then as we kind of build rough consensus on that, we can kind of discuss, put together a pull request and merge. We kind of like to take the approach like let's merge early and then refine, because you know this is still a moving target and stuff is changing, but it's kind of what we're doing so far. Yeah, but I encourage for anyone who has like any suggestion, whether it's adding or removing the set of FHIR path that we would support, or like type information or anything else. Yeah, I think that the GitHub issues has been a good place to discuss it. And then we've also found it helpful like to ping the Zulip as well. It's like with a link, hey, there's this discussion over there, just to help with some visibility too. But yeah, there's obviously a lot of questions to answer, and I think that's been a good channel to do it in addition to these meetings. It's like we're making good progress. So yeah, appreciate everyone's time.
Thank you guys. Yeah, see you on Zulip.